The direction in which one object lies in relation to another object can be given in two ways. One way is by compass directions, and the other way is by bearings. In a compass bearing, these are the cardinal points, and these are the intermediate points. And these compass points give the general direction of one object to another. For example, in this illustration, the ship is northeast of the port, and the lighthouse is northwest of the port. However, bearings give more precise information of one object's relation to another. In order to understand how accurate bearings can be, there are three important facts you must remember about bearings. Bearings are always measured from the north. Therefore, the first thing we have to do when calculating a bearing of one object from another is to identify the position of north. The second thing we must remember about bearings is they are always measured in a clockwise direction from the north. For example, once we have found the northern position, we turn in a clockwise direction until we are pointing to the object we want to find the bearing to, and the angle between the north and the direction towards the object is the bearing. And the final thing to remember about bearings is they are always written using three figures. And these three figures are based on the degrees of a circle from 0, 0, 0 degrees pointing north to a complete revolution of 360 degrees to face north again. Look at this example. Here we want to find the bearing of A from B. In other words, we are standing at position B and looking towards position A. We start our calculations by pointing north at 0, 0, 0 degrees. We then turn in a clockwise direction until we are facing position A. And the angle we have turned around will be our bearing. And remember, this bearing is always given as a three-figure number. In this example, we have been given an angle of 60 degrees and have been asked to calculate the bearing of A from B. Now, a complete circle is 360 degrees. If we now take away the 60 degrees from the 360, we will calculate our bearing, which is 300 degrees. Similarly, in this example, we have been given the angle of 140 degrees. We subtract 140 degrees from 360 degrees, which gives us a bearing of 220 degrees. Sometimes we will be asked to calculate what is known as a back bearing, and these back bearings require us to draw a second northern line parallel to the first northern line. And then we use the angle properties of parallel lines to calculate the bearings. Look at this example. Here we have to calculate the bearing of A from B. In other words, we are at position B and we want to calculate the bearing toward position A. So this is the angle we are interested in. Now, the angle properties of parallel lines state that supplementary angles add up to 180 degrees. So if angle NAB is 130 degrees, then angle ABN is 50 degrees. Now remember, this is the angle we are interested in, because a bearing from position B towards A is always taken from the northern position. So this angle can be calculated by subtracting 50 from 360 degrees, which gives us a bearing of 210 degrees. In this example, we want to calculate the bearing of A from B. So once again, we are at position B looking towards position A and want to calculate the bearing. Again, the angle properties of parallel lines tell us the corresponding angles are equal. Remember, all angles on a straight line total 180 degrees. We can see that this angle is worth 180 degrees. So our bearing of position B towards position A from the north is 50 degrees plus 180 degrees, which comes to 230 degrees. Remember, bearings are always taken from the north and are measured in a clockwise direction, and any bearing you write down has to consist of three figures.